Okay, so we're going to be solving now a rational inequality, and it's solved somewhat like a polynomial inequality, except you get some more extra critical numbers. And if you have to combine some fractions together, that can get a little difficult as well. So this one doesn't have more than one fraction, so the solving should be pretty easy. The only difference from the polynomial inequalities is that we have a denominator, and undefined points from the denominator are critical numbers. So we're going to start by taking our denominator, set it equal to 0, see what makes that function undefined, and that is your first critical number. It's an undefined point. It's going to have an open circle. So make sure when you graph, you know it's open circle. And once again, it's an extra critical number. And then we're going to solve the related equation. So we're going to take that fraction, set it equal to 0, and solve it. First thing I'm going to do is just multiply both sides by my denominator of x plus 6. The reason I multiply by x plus 6 is so that my denominator cancels out on the left, and then what you do to one side, you do to the other. The nice thing about multiplying the right side by x plus 6 is that you're just multiplying by 0, and anything times 0 is 0. And then I'm going to divide by 3, and I get x is equal to 0. So there are my critical numbers. I have two critical numbers. My undefined point at -6, definitely open circle for sure, no matter what my inequality symbol is. And then x is equal to 0, and I have to look at my inequality symbol to see if I have the equals or not, and I don't. So this will also be open circle. And then I'm going to bring over my original problem to substitute into. There was really nothing to factor, so it is what it is. So let's start subbing into it. I will have one factor on top and one factor on the bottom. Okay, so if I substitute a -7 into my numerator, I get -21. And if I substitute a -7 into my denominator, I get -1. And a negative divided by a negative is a positive, and is a positive less than 0? The answer is no, so this is false. And let's go ahead and try something in between here. I'm just going to try -1. Doesn't really matter what you try in your interval. So -1 times 3 is going to be -3. -1 plus 6 is +5. And a negative divided by a positive is a negative overall result. And is a negative less than 0? The answer is true. So we're true here in the middle. And let's go ahead and try something over to the right of 0. I'm going to plug in a 1. I get +3 on top. On the bottom, I get +7. And a positive divided by a positive is positive. So the last section is false. And then we're just going to shade in the middle. And my final answer is -6 to 0, not including those endpoints or critical numbers. All right, example 2 is a little tougher because when I bring my second fraction over to set my inequality to 0, it's a little difficult to combine the fractions together. So let's go ahead and move everything to one side. I'm going to subtract that second fraction from the right side and bring it over. And then I need to find a common denominator and combine my fractions together. Anytime that you have more than one fraction, you want to combine them into one fraction, whether you're adding or subtracting. So we find a common denominator. Just going to multiply the two separate denominators together. And then I need to multiply x plus 4 by something, by a factor. I knew if I switched colors that was going to be a mistake. I should have just left it. But I need to multiply x plus 4 by something. By a factor to turn it into the common denominator, and what I need to multiply it by is x minus 5. And whatever you multiply your denominator by to turn it into your common denominator, you need to multiply your numerator by the same amount. So on the top, we end up with x minus 5 times x minus 3. Then I'm going to bring down my subtraction sign. Okay, same procedure on the right here. What do I multiply x minus 5 by to turn it into the common denominator? I have to multiply it by x plus 4. Whatever I multiply denominator by, multiply your numerator by the same thing. So I get x plus 2 times x plus 4. And now both fractions are combined into one. And we got to clean it up still. So I'm going to FOIL out the first fraction. Now I'm nervous. I'm going to change colors and everything is going to not work. Okay, just cross my fingers. So let's start foiling. We get x squared minus 3x minus 5x. So we get negative 8x when we combine the inner and the outer terms, and plus 15. So that's the first, x minus 5 times x minus 3 foiled. Now we're going to FOIL out the second set of binomials. You get x squared plus 4x plus 2x will combine to 6x plus 8 all over x plus 4 times x minus 5. Now you do not need to FOIL out your denominator. You absolutely can just leave it alone like every single time. But we do need to finish cleaning up that numerator. We get x squared minus 8x plus 15. Distribute our negative, you get negative x squared minus 6x minus 8 all over my unfoiled denominator. Just leave it alone. And my x squareds are going to cancel out. And then I combine like terms. I get negative 14x plus 15 minus 8 is 7 all over x plus 4 times x minus 5. And then the last thing that I would do for this problem is I would factor my numerator. So that when I'm substituting back in on my number line, calculations are easy to mental math. Would take out a negative 7, and then we would be left with 2x minus 1, and my denominator still factored, x plus 4 times x minus 5, and our inequality symbol was greater than or equal to 0. Okay, so I'm going to continue to solve this problem. I'm not done yet. I have the negative 14x plus 7 over x plus 4 times x minus 5 equal to 0. So I haven't solved the problem yet. All I did for a minute was factor my numerator and bring it down to my testing area where I test my intervals. I still have to now go back and finish completely solving this problem. What I'm going to do is the same thing I did in the very first example. I multiplied both sides by the denominator. I am going to multiply the left side by x plus 4 times x minus 5 because that is going to cancel out my denominator for me. So I can finish solving. What I do to one side, I do to the other. I multiply the right side by the same thing. X plus 4 times x minus 5. X plus 4 times x minus 5 times 0 is just 0. Over here on the left, those factors will cancel, and negative 14x plus 7 is going to come down. The reason that you don't have to FOIL your denominator ever on the left side as you're working through is because when you multiply both sides by your denominator, it's going to cancel out anyway, and on the right side it's going to just multiply by a 0. So you don't even need to mess with it at all. It's going to go away, period. And then you can solve what's left over, which will be your numerator set equal to 0. This is going to happen each and every time if you solve the way I did and combine your fractions together. So let's finish. Negative 14x is equal to negative 7. Divide by negative 14. And x is equal to a half. That's one of your critical numbers. Now I have a couple more critical numbers that I did not find yet. And that is where your denominators are undefined. So we also have to take x plus 4 and set it equal to 0. And you get x is equal to negative 4. We also have to take x minus 5 and set it equal to 0. And you get x is equal to 5. So you have two critical numbers that make your polynomial your rational inequality, that make that rational inequality undefined. You have two critical numbers undefined, and then you also have the critical number you get from solving the rational inequality like all by itself. And I'm going to put the numbers in order on the number line. We have negative 4 first, then we have a half, and then we have the 5. And the two undefined numbers are going to have open circle, guaranteed, no ifs, ands, or buts. The undefined critical numbers are always open circle. And the 1/2 there is going to be closed circle because of the original symbol is greater than or equal to. And so now we just have to test a value in each region. And I'm going to have 4 factors. I have 2 of them on the top and 2 of them on the bottom. It's not as bad as it looks if you keep the problem completely factored. The reason that we combine the 2 original fractions into one is so that when you're plugging in right here and substituting in each region, it makes it just easier to do. It also makes this step up here work out really nicely when you multiply both sides by the denominator, and it quickly wipes out that entire denominator out. That's another reason for combining your fractions together into one. Okay, so the first factor of negative 7 is always going to be negative. That doesn't change because you're not plugging in an x there. But the other 3 factors, there's an x to plug into. So let's see what happens. Let's go ahead and try negative 5. If I plug in a negative 5 up in the top factor, I get a negative result. If I plug in negative 5 in here, negative 5 plus 4 is negative. Negative 5 minus 5 is negative. Overall result is positive, and that's true. Okay, in the second zone, I'm just going to try 0 because 0 is nice to plug in. And so when I plug in a 0 for the top right factor, I get a negative result. When I plug in a 0 on the bottom here, bottom left, I get positive, and bottom right, I get negative. Overall result is negative, and that is going to be false. So negative is not greater than or equal to 0. When I plug into this region right here, I'll pick a 4. When I plug in a 4 into this factor, 2 times 4 is 8, minus 1 is 7, that's positive. Put a 4 down to the left, 4 plus 4 is 8, that's positive, and a 4 minus 5 is negative. And then the overall result is a positive, and a positive number is greater than or equal to 0. And then we'll go ahead and plug in a 6. 6 times 2 is 12, minus 1 is 11, that's positive. 6 plus 4 is 10, that's positive, and 6 minus 5 is going to be positive, and the overall result is negative, so that last section is false. And finally, we're going to write this interval style. We go from negative infinity up to negative 4, not including that 4, unioned with, I just made a mistake, union with 1/2 with a bracket, including that critical number up to 5, and the open circle says use a parenthesis. Now I know this problem is tough, and I combine my fractions together rather quickly in blue there. So if you don't know how to combine two fractions together, then that's going to be an issue with solving any problem that has two fractions in it, and that needs to be taken care of like separately. Same thing with factoring. If you don't have factor, learning to factor like inside this problem is not going to be very helpful. Like off to the side in another lesson or with some extra help just separately on that topic is what you need to do before you like finish attempting this type of problem. So you are going to, as a recap, take your two fractions, combine them into one. Then you are going to solve the equation that you have left. That's going to give you one critical number or two critical numbers depending on what you end up with when you solve, whether it's linear or quadratic, and so on. Then you also have some critical numbers that you get from the undefined points when your denominator is equal to 0. Those automatically are open circle, so when you're graphing, make sure you just keep that in mind. And then finally, the reason that we do combine into one single fraction is not only does it make solving easier when your denominator gets wiped out at the step that I have circled up at the top here, but it also makes substituting in your test values a lot easier as well.